Welcome everyone to New South Wales DPI Dairy webinar number 2. This webinar will be on automatic milking systems and the type of robots that are available. I will be hosting this webinar myself. My name is Nicolas Lyons. I am the Development Officer for Robotic Milking Systems. This is a national role that has to support the technology adoption on Australian dairy farms, and I'm here to help farmers and service providers have access to the best information that is available to take the best informed decision that they can. So this webinar follows on the webinar number 1 that we had in October that talked about the generalities about AMS. In this webinar, the agenda for today will cover the following items. We will start talking a bit on conventional milking systems, just a brief overview of what is available. Then we will review the key concepts of AMS specific to this webinar. Then we will discuss the core of this webinar about the type of robots that are available for farmers and the differences between these robots. Then we will look at other robotic options available for dairy farmers, and we will conclude. The aim is to run this webinar for 30 minutes, so we hopefully will be on time and allow some time for some extra questions. So we will cover what is the basic type of robots available. We will not be covering specific or particular descriptions of brands. We will be very generic in regards to the type of robots and what are the main differences between the technologies. So conventional milking systems. Basically, there are 4 types of conventional parlors that are installed in Australia aside from robotic milking. The first one is the walk-through parlors. Roughly according to a survey made by ABER in 2010-2011, 7% of the dairy sheds in Australia are walk-through parlors. I suspect that this has been reduced since then, but basically that was the common parlor years ago. But the problem is that it is not very ergonomic for the people working in this type of installation, as you can see in the picture, and they have low throughputs in regards to cows per hour. Then the technology and the development of milking parlors transition to what we call swing over or double up parlors that can be either herringbone or parallels, and herringbone or parallels are determined by the angle of the cow in relationship to the pit. But basically swing over parlors, one milking unit, like the one in the picture below, is shared between cows on both sides. Whereas in double up parlors, there is one milking unit on either side of the pit. Basically, according to the same survey by ABER in 2010 and 11, 53% of sheds were swing overs and 27% of the sheds were double ups. The latest developments were probably the rotary parlors that came into place, that those are internal or external rotaries, that roughly 14% of the sheds at that time of that survey were rotaries. These are more capital intensive, but they have a higher throughput in cows per hour, and they're much more labor efficient because you can milk larger herds with less people. Obviously, these sheds have been available for many years, and there are many brands that are offering these type of sheds. When we move towards the latest technology, we go to the automatic milking systems. As we've discussed before, the first commercial farm milking cows with robots was in 1992 in the Netherlands. They arrived in Australia in pasture-based systems in 2001, and since then, to date, 38 farms are operating with robots milking over 10,500 cows, harvesting almost 60 million liters per year. And in that map on the right, you will be able to see the distribution of AMS farms in Australia. Basically today, every dairy region and every dairy state has farms that are operating with robotic milking systems. It is still a small proportion of the industry, but growing in interest and adoption. So what were the key concepts of AMS? Basically, they were that those systems were automatic Generally, they tend to be voluntary or voluntary cow traffic and distributed in regards to the milking. They don't have milking sessions. Milkings occur distributed throughout the day. The specific part that goes towards the webinar of today is the part of automatic. What did automatic mean? It meant that robots perform all the milking related tasks. So human is replaced and there's a robot that performs all the milking related tasks. What could those two tasks be, or what can the robot technologies do? All of them identify cows, are able to clean teats, are able to identify, locate, and attach cups on teats. All the milkings occur at a quarter level, so all the quarters are milked individually and separately, measuring a whole set of parameters and values in those quarters and the milk produced. Then the cups are removed, teats are sprayed, and the cow is able to be directed to different areas. And all that information of all this process is kept on a computer, and the farmer must monitor reports and alerts and graphs to be able to determine what is happening on the farm. What can most AMS available in the market today do? Most of them can feed cows. Most of them can divert milk to different destinations. Most of them are able to put a wash through the system at determined times of the day and are able to herd test the cows during the milkings. What can't an AMS do? And that is why we say that it's only a new way to milk. It's more than a new way to milk cows, a new way of farming, but it replaces labor in all the milking related tasks because staff and farmers still need to allocate feed, collect calves, herd cows that do not voluntarily move to the shed, change filters, hose yards, allocate feed, check cows for health issues, reproductive issues, inseminate cows, etc. So there's still a lot of works that need to be done on the farm. So specific to this webinar today, what type of robots are available? Basically, I could consider that there's 3 types of robots available for farmers deciding to invest in this technology today. There are single box robots, multi-box robots, and the robotic rotaries. Those are the 3 main categories of technologies available to farmers. Below you will be able to see one of the first prototypes of robotic milking systems. That is a picture that is prior to 1992, so it is quite old, but it shows how the first development of the technology was. So what is a single box robot? In a single box robot, there is one robotic arm per milking stall. So that robotic arm attends that milking stall and sits next to the cow or below the cow while the cow is getting milk. So the robot is available as soon as the cow walks in to the stall. These type of single box robots are probably the most common type of robots available and installed currently, not only in Australia but worldwide, and they are catered for around 65 cows per box. They can perform around 150 milkings per day and harvest 2,000 liters per day per box. These are roughly general targets or averages. Of course, if the milking frequency is lower, we can manage much more cows per box. But if we want a higher milking frequency, the number of cows has to be reduced a bit. These systems have a higher throughput per box, but a lower throughput per robot, because there's a proportion of the time that the robot is sitting next to the cow and not performing any task. So 2 pictures of those robots where you can see the robotic arm per milking stall. These are 2 brands that are available. Here the cow is being milked and the robot arm sits below the cow, and in this one the robotic arm sits next to and below the cow while the cow is getting milked. When we look at single box robot adoption in Australia, currently out of the 38 farms that are operating with AMS, 31 of them, that is 82% of the AMS farms, have single box robots. And that is in a range between 2 and 8 units. So they're milking between 110 and 500 cows. Roughly, the single box robots are milking 7,700 cows. That is 73% of the cows that are milked with robots in Australia. And they are being adopted in systems, in pasture-based systems, feedlot or corral systems, and indoor or kind of freestall systems. So there's a wide variety of adoption of these type of systems. The two main brands that are offering this technology in Australia are Delaval and Lely. Delaval offers the VMS and all the versions of the VMS, and Lely offers the Astronaut A4, and they all have different options of additionals that can be added up to the technology. So for those of you that are interested in this technology, I encourage you to contact these suppliers to access for more information or particular details of that technology. What other type of systems of single box robots are being offered overseas? Currently, we see that Fullwood offers the M2 Erlin or the Merlin robot. Bomatic offers the MRS1 robot that is on the top right, and GEA offers the Monobox robot that is on the bottom middle of your screen at the moment. So those are not currently offered in Australia, but yes, are offered and sold overseas. So that was the single box robot. Then we moved to what we call the multi-box robots. In this technology, we have one robotic arm per multiple milking stalls, between 1 and 5 milking stalls. So this means that we have one robotic arm that performs the same tasks in more than one milking stall. So the cows might need to wait for the robot, but it also means that we can achieve a lower throughput per box, but a much higher per robot. Because as soon as the robot finishes performing the operation on one cow in one milking stall, it can move to another cow in another milking stall. So the idle time on the robot is lower. Two pictures of two farms in Australia operating with this technology are seen in the screen at the moment. On the left, you will see that this robot is attaching the cow here, but then while this cow is getting milked in this robot here. So it already attached this cow here, and it has moved to this cow here, and it's attaching this cow here. Whereas on the right screen, you can see that the robot is attaching this cow on the right, while the cow on the left is being milked. Yes, so you can see that the robot arm is performing a task where a cow in another stall can still be performing the milking operation. So when we look at the adoption of multi-box systems in Australia, there are currently 4 farms operating with this technology. That is 11% of the AMS farms. Those farms range between 1 and 4 robots that are operating between 2 and 14 stalls. So those systems are managing between 150 cows and 600 to 800 cows. These systems are milking 1,300 cows, that is 13% of the AMS cows, and they are currently operating in pasture and indoor or freestall farming systems. This does not mean that they cannot operate in feedlot or corral systems. It only means that the current adoption has been in pasture and indoor systems, but they are of course available to operate in any type of system. The two brands that are offering this technology in Australia are GEA Farm Technologies in the left with the MI1 robot, and Davies Way offering the Incentec Astrea 2020 on the right. You will be able to see the contact details of the websites for both brands. I again encourage you to be able to contact both brands to get more details. The main difference between these two brands is that GEA can operate one robotic arm between 1 and 5 milking stalls, and Incentec or the Astrea can operate one robotic arm in up to 2 milking stalls. That is the only difference. Other multi-box systems that are offered overseas are the SAC brand, offering the RDS Future Line Max robot on the left, and Bomatic offering the MR-D1 robot. So those robots are not available over in Australia, but are being offered and installed overseas. The third category is what we call the robotic rotary category. In this type of technology, we have multiple robotic arms that are either rotating or fixed, attending different bales or milking points on a rotary. We have different configurations, so the rotaries can be external or internal. We have different functioning and managements in place, but in general, they can achieve a higher throughput in cows per hour. So whereas the single box can milk around 7 to 8 cows per hour, the robotic rotaries can milk anywhere between 90 and 450 cows per hour. Two pictures of the robots in this type of technology are seen in the screen at the moment. In the left, you see an external rotary where the robotic arm is in each bale. And in the right, you can see an internal rotary where the robotic arms are not rotating, they're fixed, and it's an internal rotary milking the cows. Here there's a mistake in the slide. The robotic rotaries in Australia have been adopted on 3 farms. That is 8% of AMS farms in Australia. They're milking around 1,500 cows. That is 14% of AMS cows, and they have been adopted only in pasture-based farming system. Once again, this does not mean that the technology is not able to operate in feedlot coral systems or indoor freestall systems. It only means that in Australia they have been adopted in pasture-based systems. The 2 brands offering this type of robotic rotary technology are GA Farm Technologies, offering the Dairy Pro Q robotic rotary that can be installed in sizes between 28 and 80 stalls, milking anywhere between 150 and 450 cows per hour, and the Delaval automatic milking rotary, or AMR, that comes in 24 units, has 5 robots, and can milk 80 to 90 cows per hour, or perform 1,500, 1,600 milkings per day. So both those 2 are the brands that are offering this type of technology. Once again, I encourage you to contact the supplier of these technologies to gather more information of this type of technology. What could future developments look like? Honestly, I don't have the whole scope or range of technologies that are being developed in robotic dairies. But what we do know is that there's a company called Scott Milk Tech that is based in New Zealand that is currently developing and working on a retrofit robotic system that can be retrofitted to an external rotary to milk cows. It is not envisaged that this will replace human labor completely. It will be able to replace 1 person at capson. This is what the people that are doing the development envisage at this stage. It is very early stages, but it's just to show you a picture of what is being developed around the world. So what are the main differences between the technology that we've discussed before? There is the single box robots, the multi-box robot, and the robotic rotary. Number 1 is the number of robots per milking stall. The single box has 1 robot per milking stall, whereas the multi-box robots share the robot between different milking stalls. The second difference is the number of units according to the herd size. Every farmer will need to cater and plan according to the type of farming system, how they want to run the system, if it's batch, voluntary, the herd size, the target milking frequency, the yield that they want to achieve, the level of utilization of the robot that is possible, or related to the downtime and the wash cycles. But according to that, you will determine which number of units you will use of each type of robot. According to that, there will be a difference in associated investment according to each technology. Multi-box robots tend to be slightly cheaper, but for example, if you compare two single box robots with one multi-box robot that shares one arm in two milking stalls, it's not that the multi-box robot costs 50% because one arm can cater for two boxes. So there is a reduction in cost, but it's not proportional to the amount of stalls that it's catered for. But again, I encourage you to contact the suppliers to get more details of information of the costs. The fourth difference is the possibility of a cow having to wait for the robot. Of course, in a multi-box robot system, as in the AMR, the cows might need to wait for the robot to be available to perform the attachment to the cleaning tasks on that cow. This does not happen in the Dairy ProQ or the single box robots. But according to the flow of cows, it's not that the cow will have to wait for 6, 8, or 10 minutes that the cow is getting milk. And I tell farmers that this is exactly the same that happens in a swing over dairy. And if you remember the statistics that I mentioned at the beginning, the 53% of the sheds were swing overs, and cows have to wait for the cow getting milked on the other side. Then robot utilization. Of course, a multi-box robot will have a higher utilization of the robotic system. Then each system will have a different throughput in cows per hour per robot. And each system will vary in how will you plan for future expansion. And I will tell all the farmers, try to plan for future expansions, because farmers tend to expand in size and you need to cater for that expansion. So allow for an extra robot to be installed in your dairy in the future, because this might happen. And I will go on those numbers later on. But we've seen the same happen in conventional dairies. So people say, okay, multi-box robots are easier to expand because I can install one robot on one stall, and I can then expand by installing different stalls, but I don't need to install another robot. So if we look at the two brands available in Australia at the moment, those that go for the GA MI1, you install one box system robot. So there's one robot attending that stall that is basically the same as a single box robot. Then if he wants to expand to another stall, he just buys another stall and the same robot caters for two stalls. If he wants to expand again, he buys another stall and so on until he buys 5 stalls that are operated with that same robot that installed at the beginning. If you decide for the Incentec Astra 2020 that is supplied and serviced by Davies Way, you buy one robot attending one milking stall. If you want to expand, you buy the other stall. You install the other stall, but you use the same robot. If you want to expand again, you have to buy another robot and one milking stall. If you want to expand again, you just buy an extra stall for that second robot, and so on till the farm goes expanding. But this does not mean that only multi-box robot systems or robotic rotaries are catered for large herds, because the same can happen with a different level of investment and different impact in the system, but it is available with single box robots. If you look at single box robots, for example, the De Laval VMS, one farmer can start with one robot and 60 cows, and then purchase additional robots to expand and cater for the increase in herd size. The same can happen with the Lely Astronaut A4, one robot, 2, 3, 4, and like that, according to expanding herd size. The level of investment of what is meant or the impact of expanding will impact according to the different technologies, but it is possible to expand in any type of technologies aside from the robotic rotary. Of course, if you buy a rotary of a certain size, you cannot make the rotary bigger or smaller. Yes, you will need to install a new system or a different type of system. So if we look at what has happened with the single box robot expansion in Australia, out of the 31, I think it was, farms operating with 31 single box robots in Australia, current AMS farms, 9 have increased their operation. So that's more cows and more robots since commissioning. So they started with a certain number of robots, let's say 3 robots, and after a certain time, they purchase an extra robot. So it is possible to expand your system if you're operating with single box robots. And then I asked farmers, we organize an annual AMS gathering for all the AMS farmers once a year where we all come together. I asked how many would consider expanding. 72% of them would consider expanding within the next 5 years. This was an answer given last year. So it is possible to expand with any type of technology. What other type of robotic options available? This is just to give a wide overview. It does not have to exactly to be with robotic milking, but other robotic type of technology or automation available for farmers, and I'll go over some of them. One is teat spray. It's a teat spray that can be retrofitted to an existing rotary and be able to spray cows on an external rotary. The other are feeding systems. So you can see these three type of systems are able to ration feed, so the farmer can set a ration. The system is able to, through augers and system, mix the ration and deliver the ration to the cows. This all is done automatically. This type of technology is able to push the feed to the bunker that encourages intake and visit to the feed bank. Other type of robotic options are calf or cow feeding system. So robotic is here, and I don't think it will leave soon. Because why? I think the technology and automation has arrived here to stay, because there's a shortage of labor, and we are moving to a more technological type of farmer where data is being able to be captured and use that data captured by sensor to take better informed decisions. So nowadays it is not common to see farming or dairy related to words such as precision or smart or intelligent, because it's every time more automated, more technological, more sensors, more data being captured. So one example of what the future could look like is the University of Sydney, together with the Australian Centre for Field Robotics, is developing a robot that is an autonomous vehicle that is able to go to the paddock and be used for different tasks. For example, why not thinking about this robot to collect cows and bring them to the dairy, but also try to find which cows are on heat, and in the meantime measure pasture. So I think the possibilities are endless, and we are at very early stages of what is to come in the future years. So any of you that is interested in more information can access basically two sources of information, aside from the suppliers that I've just mentioned before. One is Dairy Australia has an animal technology section where you can access these two fact sheets on automatic milking systems that I developed in conjunction with them, but you will also be able to access tech notes on different type of technologies. Then you have Future Dairy, that is an industry project that has been running for many years, for over 10 years, that is working on the challenges that farmers are facing into the futures with a specific focus on automatic milking system. And then I am available for anyone that wants to contact me regarding information on precision technology and robotic milking. And I coordinate and manage the New South Wales DPI Dairy Facebook page. You can have a look at it, and we post regular information on that. And I have a quarterly newsletter that comes out with all technologies, and it's aimed for farmers and service providers. There's been 3 issues already being issued, and they're available for those that want to access it, and there's more to come. So as a conclusion, AMS is an established way of farming. It has arrived here and it will stay here and overseas. There are many options available. No one size fits all. There are single box robots, multi-box robots, and robotic rotaries. I encourage you to contact me for more information, or the suppliers. Every option has advantages and disadvantages, and again, no one size will fit all, so you will be able to see what fits your farming system. All of them can work in different farming systems, and farmers must do their homework. And by that I mean contact people, contact all the suppliers, visit farms that are doing the job, because they are the ones that know what is happening, and they will be able to tell you firsthand what is available and how does it work on their farms. So having said that, and hitting 31 minutes of the webinar, I thank you very much all for your attention. You will be able to see in the screen my contact email address. Feel free to contact me at any stage if you have any question, and I open the panel for questions if you want. There has been one question That is, Nico, what's the average size of farm that adopt each type of technology? Do you get better economies the larger the herd? That's a very good question. The average AMS farm in Australia is operating 240 cows with 4 robots. So that's the average. Single box robots range between 2 and 8 units, milking between 110 and 500 cows. Multi-box robots have been adopted with 1 to 4 robots, that is 2 to 14 stalls, milking anywhere between 150 and 6 to 800 cows. And the rotary farms are the ones that have been adopted is the AMR, the De Laval AMR, that has 5 robots on a 24 bale rotary that are milking between 350 and 600 cows. Do you get better economies the larger the herd? I think that is what we've seen conventionally is that the economies or the financial performance is not that related to the farm size, is more related to the management skills. I can refer you to the Dairy Farm Monitor project that DPI New South Wales runs in New South Wales, but other organizations run in other states, where you can monitor different farm sizes and see how they are performing. The results for that for last year are available already on our website, and we are soon starting after July the data collection for the current financial year. I am currently running a project on monitoring key performance indicator on 9 AMS farms that is available on DPI's website. I monitor those 9 farms on a monthly interval, and those results are available online. That is production and performance indicators, and we've currently enrolled at least 8 farms that will hopefully put their data into some benchmarking to see how AMS is performing. But again, if you see that 9 out of the 38 farms that are running have expanded the system, this means that there is a certain profitability in the system and you can be profitable. It just depends and goes down to the management itself. Is there any other question? I can open the panel to open discussions. I will unmute all of you and ask you to speak one at a time if you want, but I will open the panel for questions or discussions if you want. So now you're all able to talk if you want. Okay, there appears to be no other questions. There are some other questions here. Nico, we are also seeing greater milk production volume per cow with 3-way grazing system predominantly adopted. Currently, there are farms in grazing systems operating with 2, 3, and up to 4 way grazing or allocations per 24-hour period. Again, I encourage you to visit the KPI projects because there you will be able to see how many allocations those farmers are managing and what level of productions or performance those farmers are achieving. So if there are no other further questions, I will once again thank you all for joining this webinar. It is really encouraging to see people join and jump on board this journey of technology adoption in the Australian dairy industry. This webinar will be available at a later stage on our website. And for more information, I encourage you, all of you, to visit the New South Wales Department of Primary Industries website. There is a dairy section there, and you will be able to access not only the Dairy Farm Monitor project that we've mentioned before, but there's also a section on robotic milking system where you will be able to see a lot of tools and resources that are available both for farmers and service providers that are interested in this technology. So thank you very much for joining, and hope to see you next time that we deliver this type of presentation through a webinar. Thank you very much.